Thank you, Warren. I'm very honored to be here and to present our technology, our ICI microscopy, which is a combined 2D and 3D imaging technology for microscopic use and for 100% inline inspection. As a research institute, we always strive to solve unsolved problems so far. And we identified needs. The needs are from modern high-performance production processes they need combined 2D and 3D imaging down to a microscopic range. And these systems need to cope with a broad range of surface properties. And they need to go for 100% inline inspection. Besides, they need to be precise to cope with ever stricter tolerance values, and they need to be easy to integrate and also adaptable for future needs. So this was our starting point. And we developed a technology called Inline computational imaging, which uses light field and photometric stereo combined, and therefore it can go with a variety of surface properties. We deliver point clouds together with computational optimized 2D color images, and we deliver up to 60 million 3D points per second. Of course, this technology also can do work in macro and in micro range. As the output, we have 2D data, meaning point clouds, depth maps, and confidence maps. We have also 2D data, albedo, computational bright field, dark field, and all in focus images. And if you have other ideas, we can make happen as well. And we also have 2D gradients to give the surface topography. All these data are pixel rectified at the output of our algorithm. So traditional light field and photometric solutions, they look as you see it on the left side of the image. They are bulky and therefore not so good suitable for inline inspection systems. And we came up with a solution combining light field and photometric in a smart single camera sensor, which is specifically tailored to go for inline inspection systems. We use one camera, which looks perpendicular of a transport stage where the object is positioned, and we have 4 to 6 illumination directions. So there are the hardware components. Of course, we need a lens as well. And here, some results. When you are inspecting a microscopic component, a ball grid array, this is at the size of 10 times 10 millimeter with soldier balls in the height of about 120 micron, let's say. Oh, wrong direction. And yes, using our inline microscopy solution, we can deliver, on the right side you see the depth map, where you can measure the height of each single bump, identify whether there is one bump too high, too low, or if there are some dust particles in it. You also can use the color image to identify whether the copper layer is present or if there is a layer, a wire missing. And we also have the gradients to identify some cracks or pores. And another example, inspecting a highly glossy print plate, which has some laser engravings on it to carry the print ink to the paper. Also, this kind of highly glossy surfaces can be reconstructed and measured with the ICI microscopy. So scanning this with our system can give us data where you can measure the depth of all these engravings. And a little bit about the technical specifications. So we use 700 nanometer sampling rate. With the camera we have in use now, we have then a field of view width of 1.6 millimeter in transport direction. Since it's a scanning microscope, we can make arbitrary lengths visible. And if we want to scan larger areas, as it is, for example, for this ball grid array, we can scan lane by lane and stitch the results together. We have a depth of field in this kind of configuration of 160 micron, which also can be adapted somehow, and acquire at the speed of 12 millimeters per second. These 6 illumination directions we have, they help us to cope with gloss and to reduce the gloss, and especially for metallic surfaces, we are delivering good results with this technology. And to sum up, the technology is fast. We acquired 7 millimeters per second, and it's precise with 700 nanometer per pixels. Therefore, it can be used inline without stopping the part in the line and to continue and to acquire continuous strips. It is flexible in use since we deliver 3D point clouds, steps, texture, and also gradient data. And it is robust and precise through this multi-viewing and illumination directions. We guarantee good performance for diverse materials. And this technology can be used in a broad range of applications. For example, to detect cracks, measure laser cuts, to measure wire bonds, PGA, or any other kind of microelectronics. Here are some pictures we already tried to inspect with this technology. Then I want to thank you for listening. I want to invite you to come over to our booth. We have the demo here. So you can find us at booth 8C50, which is just a few steps away. And I would be happy to welcome you for a live demo there. Thank you.